Out there, beyond the warmth of the sun, something ancient is moving. A silent wanderer, older than Earth itself. Astronomers call it 3I/Atlas, the third known interstellar object to ever visit our solar system, but recently, the James Webb Space Telescope captured something impossible. A sudden flash near Mars. An object changing its course. And data that may rewrite what we thought we knew about the origins of life itself. This is the story of how James Webb just confirmed that 3I/Atlas is exactly what scientists had feared, and hoped, all along. It began like any other discovery. A faint point of light moving just a bit too fast. At first, telescopes thought it was a long-period comet. But when its velocity was measured, astronomers were stunned. It was moving faster than any object bound to the sun. That could mean only one thing. 3I/Atlas wasn't from here. It had come from another star system entirely. Like its predecessors, Oumuamua and Borisov, 3I/Atlas was an interstellar messenger. But this one was different. It was larger, brighter, and carried a chemical signature unlike anything seen before. By the time James Webb turned its gaze toward it, the comet was already nearing Mars, and then, something extraordinary happened. On a quiet morning, Webb's infrared sensors picked up a burst of light, a sudden spike in temperature near the comet's nucleus. It lasted only a few seconds, but it was powerful enough to send shockwaves through its coma, the glowing cloud of dust and gas surrounding it. Within hours, every major observatory on Earth had confirmed the anomaly. A collision had occurred, but what collided with it, no one knew. The data showed that after the impact, 3I/Atlas changed direction ever so slightly, as though something had struck its side or burst from within. More intriguing still, its rotation slowed and then stabilized into a steady rhythm. Whatever happened had rebalanced it. Some scientists whispered that maybe, just maybe, the comet wasn't behaving naturally. As Webb zoomed in, its instruments began to see inside the heart of the object. Infrared readings revealed pockets of warmth beneath the surface, as though internal vents were releasing gases in precise bursts. Normal comets outgas randomly, but this looked controlled. The spectroscopy data painted an even stranger picture. It showed high concentrations of carbon dioxide, sodium, magnesium, and even traces of ammonia ice, materials that can only form in environments very different from our own. But the biggest shock came from the isotope ratios. These were not from any known region of the solar system. They matched no meteorite, no asteroid, no comet we've ever studied. As one astronomer put it, 3I/Atlas carries the DNA of another sun. It was the cosmic equivalent of finding a fossil from a world we'll never visit, a fragment of a distant planetary system flung into interstellar space, now crossing paths with ours. So, what really happened near Mars? Some researchers believe a small asteroid fragment collided with 3I/Atlas by chance, a 1,000,000,000 event that cracked open its crust and exposed its ancient interior. Others think the burst may have come from within, a pressure buildup from volatile materials heated by sunlight after eons in darkness. But a few, led by Harvard's Dr. Amir Malik, proposed a more provocative idea. What if it wasn't a natural impact at all? His team noted the pattern of the gas release, its symmetry, and the sudden stabilization of rotation afterward. He suggested that 3I/Atlas could be a derelict interstellar probe, a piece of long-forgotten technology disguised by time and ice. While the mainstream scientific community remained skeptical, the idea sparked global fascination. After all, Oumuamua, the first interstellar object ever detected, had already displayed unexplained acceleration that no natural explanation fully fit. Could 3I/Atlas be a sibling to Oumuamua, or something even older? James Webb's instruments continued scanning the debris cloud. Within the expanding plume, it found compounds not usually seen in ordinary comets, complex silicates, metallic crystals, and rare isotopes of xenon and neon that suggest formation in the dying embers of another star. Each reading was like a breadcrumb from another world. By decoding it, scientists realized they weren't just studying a comet, they were peering into the chemical memory of a vanished solar system. Dr. Helena Rivas of the European Southern Observatory described it beautifully. Every molecule escaping from 3I/Atlas is a message written in starlight. If those molecules could talk, they would tell us of oceans frozen solid, of planets that once orbited another sun, of the collapse of that system and the birth of ours. What Webb had captured was nothing less than the story of stellar reincarnation, proof that the materials of one world can seed another. Weeks passed, instead of fading, 3I/Atlas began showing periodic pulses, faint but rhythmic flares of gas, almost like a heartbeat. Infrared imaging revealed jets erupting from its poles, aligned perfectly with its rotation. This regularity puzzled scientists. An unknown comet releases gas so precisely, so evenly, and for so long after a collision that it was as if the object were regulating itself. Even more strangely, the thermal reading suggested an organized structure beneath the crust, repeating geometric patterns, consistent with layers or compartments. Was it natural fracturing, or something designed? NASA declined to speculate publicly, but off-record conversations leaked online hinted that internal modeling could not fully explain the pattern through natural physics alone. Whatever 3I/Atlas was, it wasn't behaving like any comet ever seen. Where did it come from? Using its inbound trajectory, researchers traced its origin backward through space. The path led to a region near the constellation Lyra, where ancient stars have long since burned out. Computer models suggest 3I/Atlas may have been ejected from a dying planetary system over 1 billion years ago, hurled into interstellar space when its parent star exploded or collapsed into a white dwarf. That means this single object has been wandering the galaxy for longer than multicellular life has existed on Earth. Imagine that, a frozen survivor from a system that no longer exists, traveling alone through the dark for eons, until chance brought it here, to our neighborhood, just as humanity built a telescope powerful enough to recognize it. It's hard not to feel like the timing was meant to be. In the wake of the impact, 3I/Atlas released clouds of dust so vast that even small telescopes could detect them. Within that dust lay the secrets of its chemistry: carbon chains, frozen volatiles, traces of organic molecules, the same kind of molecules that once drifted through the young Earth's atmosphere billions of years ago. Some scientists believe that if interstellar comets like this one are common, they could serve as galactic couriers, spreading the ingredients for life from one system to another, a cosmic version of pollination. And suddenly, the mystery of 3I/Atlas didn't feel distant or alien anymore. It felt personal, because if such comets have traveled between stars for billions of years, then maybe, the seeds of life on Earth began just like this, in the shattered heart of a wandering comet from another sun. Weeks turned into months. The comet's once brilliant halo began to dim, the gases thinned. The jets grew weaker. James Webb caught one final glimpse, a faint, symmetrical glow expanding outward, like the last breath of a dying ember. No further anomalies. No second impact, just silence. But even in that silence, the data spoke volumes. The collision had transformed 3I/Atlas into a mirror, reflecting everything humanity has ever wondered about its place in the universe. Where did we come from? Are we alone? How many worlds must have lived and died before we were born? Every atom escaping that interstellar relic was a fragment of an answer, one we might not yet understand, but one that connects us to the rest of the cosmos. Today, as the comet drifts back into interstellar space, scientists continue analyzing the troves of data James Webb collected. We know now that 3I/Atlas is older than our solar system, and that it carries materials from a world orbiting another star. Its isotopic ratios reveal that not all planetary systems are built alike. Some are richer in carbon, others in nitrogen, each one shaping the chemistry of life in different ways. And if even a handful of these interstellar travelers cross between systems every million years, then the building blocks of life might be spread across the galaxy far more efficiently than we ever imagined. That's not science fiction, that's astrophysics. The universe, it seems, has always been exchanging pieces of itself, scattering the dust of one world to form another. The James Webb Space Telescope wasn't built to study comets. It was designed to look back in time, to see the first galaxies forming after the Big Bang, and yet, in watching 3I/Atlas, Webb may have uncovered something just as profound: the living connection between stars and life. For centuries, we've looked at comets as omens, harbingers of change. In ancient times, they inspired fear. Now, they inspire wonder. Because what Webb showed us isn't just a cosmic event, it's a mirror held up to the universe itself, reminding us that everything, planets, stars, and even us, is made from the same recycled stardust. 3I/Atlas is proof that nothing in the cosmos ever truly ends, that it merely changes form, drifts across the dark, and begins again somewhere new. As of this moment, 3I/Atlas is fading fast, heading toward the outer edges of our solar system. Soon, it will slip beyond the reach of our telescopes, vanishing into the interstellar night once more. Perhaps, millions of years from now, it will pass near another world, where another civilization will notice the strange visitor and wonder where it came from. And maybe they'll point their own telescope toward it and see what we saw, a fragment of history, still glowing faintly, still carrying the story of countless suns. James Webb didn't just detect a comet, that it uncovered a cosmic connection, a bridge between our past and the galaxy's infinite future, because in the end, every traveler, every star, every fragment of dust is part of one great story, and tonight, 3I/Atlas reminded us of that story, and our place within it. The universe remembers everything, even the whispers of worlds long gone.